And indeed, I am glad to be with you in the remaining part of the hour, which is obviously very insufficient to cover what I wanted to cover under remote sensing. Well, the class itself is a remote sensing process. It is making use of remote sensing process. I see only your images, you see only my images. And of course, images tell a lot. Now, I would imagine that if I walk into any place where you are also there won't be any difficulty on your part, probably I may have, to recognize me as one of the instructors in GIS in the CED Thiruvananthapuram. Now, without wasting much time, I will go into what is called remote sensing. It is only an introduction to remote sensing, and you have plenty of material available. I would urge all of you to study whatever material that was given to you by CED with the same fervor and passion that you had showed while preparing for the entrance exam, which unfortunately you did not make, so you went to a degree college or a postgraduate degree program. That apart, in other words, I am asking you to spend the time before you at least 16 hours a day to study whatever we give you and practice whatever we teach you in this course, as part of this course. This is a very high intensity course, unlike whatever you experience in your college. You are hardly given any time to, chit chat or quiet or, chat with each other over the phone. Anyway, what is remote sensing? Remote sensing is capturing the signature or signals of a distant object used without coming into contact with it. The distant object in our case is the satellites and the planet Earth, as it is under this course. But remote sensing is not restricted to planet Earth only. Remote sensing is also covering what is called the other planets in the solar system or even beyond. So, see, for example, what is the advantage? Because I see you in the screen, I can see almost practically all the attendees of the course. Whereas, if you were like one person somewhere, if I knew you, I will know you. So, there is a difference in what is called a scale. I see one person and recognize that person. I see a crowd of people and recognize that crowd. Similarly, remote sensing has such advantage. Remote sensing can look at a smaller area, a region, or a part of the hemisphere, or the planet Earth. This is achieved by what is called as satellite imaging. Well, when I say remote sensing, it is unfair not to talk about aerial photo interpretation or aerial photography, because that is the forerunner of all the remote sensing technologies that we have before us. Keep that in mind. What is aerial photo? Aerial photo is a simple system where a trained pilot, specially trained pilot, uses a certain type of aircraft to fly over an area with a camera attached to the belly of the aircraft. The camera is remotely operated in the sense it is robotic type camera. Once switched on, it will go on clicking the scene below the path of flight of the aircraft. Well, this came into being as soon as the aeroplanes were available, as well as the camera systems were available. The first user was hobbies, no doubt about it. But later, this system got into the civil society that is hobbies, and then civil administration, and above all, the defense administration of the Western society, Western world. So we have what is the advantage? The advantage is you are flying the aircraft over a terrain at an elevation of altitude of 1,000 feet or 1,500 feet at the best. So these are, what is the advantage of the image? The image has a certain geometry and the camera system has certain specifications like focal length, and the format of the film is 8 inch by 8 inch. And it is actually contact prints that are made. What is a contact print? As big as the original negative. This is the advantage. What is the specific advantage then? Specific advantage is what you find is, or you probably can identify earth surface features in a smaller area. In other words, your flying altitude is 1,500 or 1,000 feet above ground. All this, I hope you are able to see me or at least listen to me. Okay, so because your Gripse, can you hear me? Am I available in the screen? Hello? Am I available in the screen? At least wave. Okay, thank you. Thank you. So that is aerial photography. And in fact, the Survey of India, the authority in India, a national government agency who is in charge of mapping the landscape of this country, has made use of what are called the aerial photographs of the country. The entire India is a huge country, keep that in mind. In order to revise the topo sheets as of 1968, and in a new scale, and the scale is 1:50,000 units. 1 unit in the map will be equivalent of 50,000 units out in the open real world. So what it also means is 1 centimeter is equal to 500 centimeters or half a meter, half a kilometer. Yeah. In other words, every centimeter will be representing 500 meters in the field. So that is about the aerial photography. This is not the only elevation or altitude at which aerial photographs are captured. For example, surveillance aircraft are deployed both by former Soviet Union as well as the NATO countries to image the ground in the enemy territory from altitudes of 90,000 feet above. 90,000 feet above. The obvious reason is there is no way any gun, anti-aircraft gun placed on the ground can hit what is called the aircraft or the target. So that also is there. Now in 1970s, early 70s, satellite-based remote sensing was inaugurated. Before that, several Gemini program was there. It is actually a manned mission. In other words, the spacecraft has people, astronauts, and most of the time the flight path was parallel to the equator. I think you will have to learn or relearn what is latitude and what is longitude. It's very important. Our geographic coordinates. Okay? Latitudes are the lines on the globe drawn parallel to the equator. They are the latitude. Equator is a 0 latitude. And as you go to the North Pole, the 90-degree north latitude is identified by North Pole. And all these numbers, for example, if you recall, position of India is in the northern hemisphere, and it is somewhere from 8 degree north, 8 degree 30 or 28 minute north latitude to 25 or 26 minute north latitude. Whereas Australia is in the southern hemisphere, and the latitudinal values will carry a negative number, because those numbers, latitudes in the southern hemisphere are identified by a negative sign. Similarly is the longitude. Longitudes are actually, you can imagine any longitude in any way, but the Greenwich prime meridian is taken as the basis of counting or labeling the geographic coordinates. So this Greenwich meridian in Britain, Greenwich, as they say, right, in many places is a small village, and there is a meridian passing through Greenwich. And what is the specific difference between a latitude and longitude? Longitude, only longitude that cuts through the center of the earth is equator. All the longitudes, only equator is the only latitude that cuts through the center of the earth. Keep that in mind. The others are, when you talk of longitude, Greenwich meridian, it is called, and other meridians, all these lines, if you imagine these lines as part of the periphery of a circle, then the circle, center of the circle will coincide with what is called the center of the earth. So we have identified 360 longitudinal lines, 90-degree north latitude lines, and 90-degree with a negative sign to the south. So this is the latitude longitude system. This will be used quite often as part of this program. In other words, any spatial data, any geospatial data has to be tagged with a latitude, longitude number also, with a set of latitude, longitude number also. Now orbits. I told you that you have U-2 aircraft. Then I said we had let us say NASA had what is called a Gemini program, where the spacecraft was flying at very low altitude, and very low in the sense, so-called low altitude. That is 200 nautical miles or so from the Earth's surface, and parallel to the equator. And parallel to the equator, not along the longitude, only parallel to the latitude over a certain area. That had happened. NASA had released those photographs taken by astronauts using handheld cameras from the spacecraft. Of course, geologists were one of the groups who made use of these images of various deltas of the world, major deltas. There are 6 or 7 major deltas of the world. Our Sundarbans Delta in India and partly in Bangladesh, that is one among the large deltas. And in those days, the available knowledge, skills and tools, some kind of interpretation of the status of growth of or destruction of delta was assessed, and that appeared in a journal called Sedimentology way back in 1968. So then came in the 1970s when satellite-based remote sensing was inaugurated. exactly in 1972, I think May or June, a satellite called ERTS, Earth Resources Technology Satellite, was launched by NASA. And this satellite is called an imaging satellite, and this is also in a low orbit. What is a low orbit? Any orbit above the Earth but below 2000 kilometers is called a low orbit. What is a medium orbit? Any orbit for satellite between the altitudes of 2000 kilometers to 25,000 kilometers is the medium altitude. And whatever satellite orbit the scientists or technologists make use of, that is above 25,000 kilometers, are called high altitude orbits. So, in fact, INSAT is a part in a high altitude orbit. It runs to 35,000 or close to 35,000 square kilometers above the Earth. And INSAT is a geostationary satellite. For that reason, the satellite is parked appropriately only in the equator. It is not in the northern hemisphere nor in the southern hemisphere. Such satellites are parked in the equator, at the equator, so that the satellite's data, for example, our weather data is coming from one of the INSAT series, current series satellites, and there is a device, there is a sensor called Kalpana, and Kalpana is named after one of those Indian origin women or astronaut who lost her life in a mid-air explosion of space shuttle years ago, decades ago. And of course, ISRO or India Meteorological Department has named the sensor, the climate sensor or the cloud sensor, whatever, day-to-day changes, Kalpana. Then we have also what is called a NAVIC, NAVIC. NAVIC is actually a constellation of 8 satellites, and it works at sync with the GPS system, geographic positioning system, constellation of, because there are 32 satellites, out of which 24 are functional, others are just standing by. At the time of emergency, if one satellite goes fat, and another one will take over. It will be switched on. What it does is, it provides you the exact location of objects on the Earth's surface, whether mobile or immobile, as well as not only on the Earth's surface, the ground, the space above the ground also. For example, space-borne objects or space-borne devices, including aircrafts, make use of the GPS satellite data in order to locate precisely at times of emergency where they are, because at times otherwise there is no problem. Now, below this 2000 limit, 2000 and 25,000 is the medium altitude, medium orbit. The above 25,000 kilometers is high orbit, and below 2000 kilometers is low orbit. Our imaging satellites are, generally speaking, operating from the low orbits. Like 700 to 900 or 800 kilometers range. And we have 2 types of, all the imaging satellites are called sun-synchronous polar orbiting satellites. Sun-synchronous polar orbiting satellites. Why sun-synchronous? And because, the satellite rather follows the solar time. Solar time is the daytime. What is, solar? It is not the night time. Everywhere we have local time. So it is following the solar time, so that during one half of the orbit of satellite, the satellite will see the ground below or the earth surface below illuminated by sunshine, because sunshine is very critical in helping the imaging process of the payload or sensors fitted to a satellite. Imagine that satellite is like an aeroplane, several people sit in there and travel from one place to another. So similarly, there is an instrumentation system, not many, on board every satellite. For example, Indian remote sensing satellites were designated as IRS-1, IRS-2, IRS-3, etc. Indian remote sensing satellite. And the IRS-1 was, and I think IRS-2 also were launched from a Soviet cosmodrome, because designing a satellite is far more easier than designing a launch vehicle. That is the reason. Launch vehicle has to be successful, will have to be successful in placing the satellite, very expensive actually, in the correct orbit, etc. So if there is a snag in the launch vehicle, you lose the launch vehicle as well as, because launch vehicle is used only once, not reused until recently. So you lose the launch vehicle as well as the satellite. So it is a double loss. And that is the reason the initial days, Indian remote sensing satellite, that 1, 2, and probably 3 also, they were launched from Soviet cosmodromes. Yeah, Soviet cosmodrome. That is how they call it. And in IRS series, that also follows the basic concept of low orbit satellites. That is, orbiting in orbits that are below 2,000 kilometers. And also only one trouble with the IRS data is, or IRS data 1, 2, and 3 satellite-based data, they have not maintained a uniform resolution. That is the problem. Lack of a non-uniform resolution makes it little difficult for the user to monitor continuous changes taking place on the surface features of the Earth, both the natural features as well as growth of cities, reduction in the area of the agricultural land, etc., etc. So, what are the sensors? I made a use of a word sensor. IRS 1, 2, or 3, there is a pack or payload of sensors in it. The satellite has sensors, not one, many, for different purposes. Now, here, when we talk of sensors, we have to go back to the electromagnetic spectrum, the other name for our visible light included. Electromagnetic spectrum has an origin in the sun, and it has based on the wavelength. Electromagnetic spectrum has a low wavelength and high wavelength region. There is a small segment between the low wavelength and high wavelength, a small portion, which is actually what is visible to human eye. In other words, the so-called blue, green, and red colors, the primary colors as you know it, blue, green, and red colors. These 3 colors are only a tiny portion of the visible spectrum. We have ultraviolet on the one side and the infrared and microwave on the other. For example, blue wavelength is 400 nanometer to 500 nanometer. Green is 500 nanometer to 600 nanometers. Red is 600 nanometer to 700 nanometers. And infrared, including near infrared, middle infrared, far infrared, is 1.2 microns. 1 micron is 1 over 1000 of a millimeter. 1 nanometer is 1 over 1000 of a micron. And in the microwave region, beyond 1.2 micron is where our radar systems work. Radars, you may know or not know what a radar is. At least in principle, you know what is a Doppler effect, which is actually the basis of working of radar. So, the sensors up in the satellite platform, there are both kinds. Both kinds are used there. You have certain satellites making use of only the sensors that are sensitive to the visible spectrum. That is blue, green and red, and of course infrared. In addition, there will be a panchromatic. Panchromatic means so-called black and white, from the blue wavelength to the red wavelength, all combined into one image. That is so-called black and white. In addition to that, there will be blue, green and red and infrared separately with appropriate filters. And then, how does it work? That is a very important thing. You know, satellite perspective is like 700 to 800 or 850 kilometers above the surface of the earth. And you are looking at Thiruvananthapuram. Down on the right side wall, you can see the Thiruvananthapuram airport on an image from Iconos satellite. And you can see the runway, you can see the Devi temple and the so-called Indian Air Force, what is called their territory, as well as the international airport. And this image is called a false color red image. This is I think by a satellite, captured by a satellite called Iconos. Anyway, so the red color is not red in the real world. The red colored patches are green in color in the real world, natural color. In other words, a natural color captured image, it is not actually, keep in mind, we are not capturing image, we are capturing only that returned signals from the blue, green and red wavelengths that hit the Earth's surface objects and then reflected back toward the sun, but in the process it is captured by the what is called the satellite sensors. In fact, in the satellites, for example, if we have only 4 wavebands, 4 sensors, blue, green, red and black and white, then what is done is there will be 4 telescopes. And these telescopes, advantage of telescope is, telescope will bring the earth scene closer to the satellite platform before the image is captured and recorded. You know, the whole process is miniaturized in the mobile phones. When you take a picture, an image of a scene or this classroom or the way I talk to you, there is a camera in my iPad and the signals are converted. My image is converted to signals, including sound waves. And then it is transmitted via the cyberspace and then back to a receiver in the classroom at CED. So this is the process. So in between, before the signal reaches the screen, the signal is transformed to an image, either huge television screen you see in front. Just like any other television signal. Only thing is, my picture is not going, yes, signals are signature of the picture. in all aspects of the term. That is transmitted, and there is a receiver that converts the signal to an image, both sound and video, both sound and the picture. So there is no question of recording sound from the space orbit. And the first system by NASA to image the Earth's surface was called ERTS, Earth's Imaging System. ERTS, Earth Surface Technology Satellite. It carried the sensors. Only thing is, way back in 1972, those days we had only digital technology, but not the modern imaging systems. That is the difference. In other words, any camera you buy these days, including your phone camera, they are working on an entirely different principle compared to the film-based cameras of the past decades. Hardly you ever see a film-based camera these days. It is only, your image is actually from the camera, you can send it to what is called your desktop or a laptop. From there you can send it via the cyber space to whatever destination you want, or you can copy it in a pen drive. So what you have to keep in mind is, there is a pen drive-like thing in the satellite. In other words, there is a huge memory to store the signals. Now, speaking of the satellite orbits, there are something like 254 orbits, polar orbits, in order to cover the entire Earth's surface. It is not 1, 2 or 3, but 254. And in other words, you can call it 254 paths, PATH. And this is actually, finally, this 254 will work out to be 248. There is a difference of 3. And in general, Earth surface imaging satellites take a duration of 99 minutes to rise in the North Pole and descend down perpendicular to the equator to the South Pole within just 99 minutes from the visible side, from the sun, on the sunlit side or on the opposite side. An orbiting satellite, polar orbiting sun synchronous satellite, takes only 99 minutes to come down from north to south, and behind the globe, an ascending path of taking equally 99 minutes. In total, the Earth, the entire Earth will be covered by 248 such paths. That is the advantage. So, if you wanted to order a scene, an image, well, of course, how do you go from signal to image? Well, of course, there is a huge number of people working in the NASA laboratories, as well as in India, ISRO also, where the signals captured by the satellite are converted to images before it comes to your hand or our hand for various types of studies. We are not getting the signal, the raw data. Instead, we are given free of cost, keep that in mind, the images in respect of the area you want. For example, there is a mention of path and rho. So, rho is parallel to the equator, path is orbital path, and naturally these intersect. So every scene is referred to, with a path number and a row number. Now, there is what is called a resolution. Resolution is the ability of the human eye to perceive objects far or near. That is resolution. This holds good for satellite images also. Or satellite captured data converted to image. Now, before that, before I go to resolution, what I would want to do is, I would want to talk to you about the data. See, globally, there are at least 5 locations on the continent or on the islands, that is starting with Hawaii, then Alaska in North America, United States, then Colorado, and then Diego Garcia in the central Indian Ocean, and then Australia. So there are 5. In other words, once the satellite storage is nearly full, this data will be dumped to such stations, and from such stations, the records of such data. Imagine that something is a digital record only, nothing else. This data is ferried to a state called Colorado, so where there is a NASA facility where the signal is converted to images and then made available to the global users free of cost. That is another point we have to keep in mind. Satellite images are made available to prospective users without any charge. Now, so that is about what data is like, and so on. Now, we have to look at resolution. We have different types of resolutions, and temporal. There is what is called temporal resolution. What is temporal is, for example, I made a mention somewhere that the satellite crosses the equator, imaging satellite crosses the equator at 90 degrees. At the equator. In other words, equator is cut at 90 degrees. So, we have a resolution is a measure of the time it takes for the same satellite to revisit, complete an orbit and revisit the same location. When you Landsat going back to ERTS, when ERTS was inaugurated, it was very much appreciated by the world scientific community, and then USGS, United States Geological Survey, spoke to the government and got enough money to continue this program, which is now, those days itself it was renamed as Landsat program. Land Imaging Satellite Program, Landsat. So now Landsat 8 is operational. When thinking of the operational life of a satellite, like imaging satellite, it can be anywhere from a couple of days to 19 years. There is a record of both the shortest time of imaging or orbital time for a Landsat satellite as well as the longest duration. Primarily, there is electricity is required to run and maintain the systems and subsystems in the satellite. So, where do you get the electricity from? And it is only from solar panels. It is solar PV, solar photovoltaic technology that was used right from the very early days and now also. So that is, if you go to some image of a representative image of a imaging satellite, you will see two wing-like objects in the middle of which two wings attached to a cylindrical whatever object. That is the satellite platform, and these are the solar panels, and that is what generates electricity needed to run the system and subsystem. And if there is a glitch in the solar panel, then satellite is out of control, because it's all basically run on electricity. Now there is what is called a resolution. You have temporal resolution, that is how often the satellite will make a revisit, not complete revolution. For example, when there was only one satellite called a Landsat or ERTS-1, I think the revisit was something like once in 2 weeks. When they had something like 3 satellites in the Landsat series, the revisit time was weekly. Every week there is one Landsat or the other Landsat passing through the same path and row. So what is the advantage? The advantage is you can monitor weekly changes or bi-weekly changes. That is the advantage. Happening to forests, cities, or natural disasters. Going back to resolution again, higher the resolution. For example, let us say, I made a mention, topographic sheets of India currently available are in a scale of 1:50,000 as well as 1:25,000 as well as 1:12,500. How is it? 50,000 is to 1:50,000, 1 centimeter, 50,000 centimeters. Then 1 centimeter equal to 25,000 centimeters. Then 1 centimeter equal to 12,500 centimeters. In these 3 different scales, the highest resolution will be the one with a scale of 1:12,500. That's the highest resolution. And relatively speaking, 1:50,000 will be the lowest resolution in this group. What does it mean from the point of view of the user? In other words, in a high resolution image, this is actually spatial resolution. It is actually spatial resolution, that is related to space, spatial, length, breadth, etc. What is the advantage? 1:12,500 will carry more data on the ground surface objects, aggregated and printed in the proportion. Compared to 1:50,000. In other words, the area covered by the sheet is hugely different. This holds good for this kind of spatial resolution holds good for satellite images also. Landsat system always carried from the very inception, always carried a device or a imaging system which had a resolution of 30 meter, or the pixel, it is also called a pixel size, Pixel size. Pixel size is 30 meter. You think pixel as a square, a small square, 30 meter one side, 30 meter the other side. So 900 square meters will form a pixel in Landsat. Whereas the Trivandrum airport map that is pasted on the wall, that will be having a very high resolution compared to the Landsat, and therefore the pixel size will be much more. When you have a more pixel size to cover the same area, what it means is the data, the signals stored are huge compared to an image where the pixel size is large. For example, weather satellites or such other satellites, they have a pixel size of 1 kilometer, and if you think of a geostationary satellites, the Indian side of the planet Earth is only one image. That is what you have to keep in mind. What is time now? You hear me? What is time now? One person at a time.
12:25.
Okay. Can you get me Mr. Prasud?
Sir.
Prasud?
Sir, can you hear me, sir?
Yeah, I can. What you do is,
Ah.
let them see the introduction to remote sensing again. Because now it is 12:35.
Yeah.
As per the schedule, we have to quit.
Okay, sure, sir.
And in the afternoon at 3:30, I will again meet.
Okay.
Data models.
Okay, fine, sir.
No, data basis. Okay, good luck.
Sure, sir.
Prasud,
Thank you, sir.
please give them the textbooks we normally give to. Soft copy of 2 or 4 textbooks we normally give to the class. It is available in the pen drive which is somewhere inside my table, first drawer, or maybe on the surface, I don't know. Okay,
Yes, sir. Okay, thank you, sir.
thank you.